everybody. This video is one that I've been wanting to do for a while. Going over rigid strips, showing you guys how I go about molding them, shaping them, getting them into some places where, quite honestly, the flexible strips just aren't as nice. Flexible is the go-to for a lot of people. It used to be the go-to for me. Once I started playing with the rigid more, I actually kind of prefer the rigid strips. They are, in many cases, easier to work with. So I'm going to show you how I do it. And, you know, hopefully from there you get a little better of an idea of what you can do with it yourself. So as for the actual rigid strips themselves, we have 4 different variations. I'll go over those real quick. This is our SK6812 RGBW variation. All of the rigid strips are sold by the meter, and they are shipped in half-meter strips. So you will get 2 half-meter strips with one order, or with each purchase of the strips. So the way these are set, they can be cut every 3 LEDs, and there are solder pads on the back, so you can easily add in connections to them. This is a 6mm wide rigid PCB. One of the reasons we started making the rigid was actually for heat dissipation. So there is actually a benefit to the rigid in addition to some of the shaping things that we can do, in that you can have a little bit better reliability with these because of their ability to dissipate the heat better than what a flexible PCB would. So in this case, this is our 6mm wide. We do sell the 8mm flex of the SK as well, so it gives you kind of 2 options. The 8mm flex, they're still solid, they're still good. I don't want to discourage anybody from trying them, because they are definitely still very relevant, very good strips. I use them myself on different builds if it calls for it. But these are a little bit thinner, so if you have some really tight spaces, these can fit in them a little bit better, and they can be shaped and molded just the same as any of our other rigids. The next one on the lineup is our 8mm UCS 2904 RGBW. Now these, as well as the SKs, are in a GRBW color order. Anything of our RGBW lineup will be a GRBW color order. These are 8mm wide. 122 or 120 LEDs per meter. The SK was 144 per meter. So these are still really close together. You can kind of hardly tell the difference between the 144 and the 120 without putting them right up next to each other. But the benefit is that, being that we were spaced them out at 120, we were able to go with the 8mm PCB and still have that good heat dissipation with the rigid. These are cuttable every 3 LEDs. And they are 12 volt, so it is 3 LEDs per address. So definitely keep that in mind for pixel density, depending on what you're building and what your goals are. The next one in our lineup is the UCS 2904 RGBW, once again in GRBW color order. This one is 144 LEDs per meter in a 12mm strip. They are cuttable every 3 LEDs, solder pads right on the back. Definitely between the two, the 8mm and the 12, you know, if you can fit the 12, go with the 12. It is a little bit more density. If you need the 8s are solid. So between the two, it's really just more your application of what fits best. For this build, I'm actually using 8mm because it just worked better up in the tight corners. But 12mm is still solid too. And at the top of the line is our RGB version. Now these were made specifically for taillights, being that the white is not a true white. It is not the same color white that you're going to get with our other RGBW products. So definitely something to keep in mind. I'm not saying that you can't use these in headlights. You most definitely can. But when you're doing a headlight, the white is pretty important, and it's probably not ideal to have a bluish tint to it. So it's definitely something you want to keep in mind for a headlight build. The initial intent of these was taillights, being that the brake lights are so dang important. you definitely want people to see them, and they will with these. These are bright. These are 144 LEDs per meter, and they are 12 mil wide, just like the other cuttable LV3 LEDs on the back, just like the 12 mil UCS 2904. And once again, the only difference being that these are RGB, and they are in an RGB color order. They are expensive, you know, depending on what you're used to. You're used to a SK roll at, you know, like $50. These are about 100 and I want to say they're around 130. That's right now. Prices obviously do change, so definitely check the website to verify pricing. But as of right now, yeah, comparatively, that's where they're priced at. They are priced there for a reason. These are expensive. These are not SK. So I get a lot of people that think the SK are just as good. Oh, I don't need the UCS. I don't need this. I don't need that. Quite honestly, if you put better out, you can expect better customers. Like, that's just the way that I've seen it. The people that use these, they swear by them, and they have no problems getting new customers. Honestly, I use these on the builds that I do. If a UCS product will fit in a headlight, it's getting a UCS. I don't care about the customer. I don't care about what they prefer. They're getting the best. The SK I reserve for the applications where there just is no other option. So, you know, it's that kind of thing. Invest in yourself is something I say to a lot of people. Get good tools, good parts. If you are a builder, things like that are very important because they make your life easier and they make your product better. The UCS lineup, that is what it is. It is a better product, not to be confused with the SKs. SKs are solid. UCS are just on that next level. So when you see the price point difference, I just want you to know it's not a gimmick. It's not a markup. There is a reason the UCS costs what it does. I highly encourage you to try it out. If you haven't had a chance to try it, you don't want to spend the money, you're on the fence, I'd be more than happy to send you a free sample. I don't, you know, don't ask for 5 different samples. You're going to get one little section that you can check out. I'll send it to you gladly. But, you know, obviously these are expensive. I can't just be sending out entire strips. So if you do want a free sample, I can definitely do that. You reach out, you let me know. As long as I've not sent you any before, I can definitely send you a free sample. Because they are good. I believe in them. So I would gladly send you guys a sample to check out. But anyways, back to the main point of the video here. So what we got here is a board that I made using the 8mm UCS. I cut it to length for the light that I'm building, cut out strips, just different sections. So basically, I'll show you here. So I got the back of this light, and I can drop it in right like that. Slide that in there. And as you can see, so it's basically the shape of the light now. So it almost looks like an actual manufactured PCB. And that's one of the cool things about the UCS and how it can be, well, the rigid strips especially, how they can be actually molded to different shapes. So what we're going to do is we're going to make one for the other side of the light. I'm going to show you how I do it. I'm going to show you the pins that I use. I'm going to show you how I work out the shapes, cut things, figure it all out, and hopefully this will give you a little bit better of a visual of how to do it. So we got our new light here. This is the other side that needs to be done, and you'll see in here I've got rigid strips in the gills here and all that. I mean, that's all pretty basic, as well as up in the top corner, and all ran out. I got my halo in. This isn't really about building a set of Subi speeds as much as it is shaping these into the shape that you need. So I won't really be going over all that right now, just focusing on this. So first thing is figuring up what length you need for your first one. So in this case, I'm just going to go back in this side here. And I've used different methods like cardboard to come up with shapes. You just cut it to size and figure it out. But with this one, it works pretty good if you just kind of get a rough idea inside of the light there. So I'm going to cut it right about here. And that'll be my first cut. Now, I use like big wire dikes, basically. Don't use like a Dremel. You'll mess up the PCB. You'll probably start ripping copper off and stuff. The movement. You don't want to use any kind of a power cutoff tool. I've heard people use like some really beefy scissors. I guess that might work. Ultimately, you want a cutting motion. I love these. I use these every time. They've not worn out on me. They still work great. These would be my recommendations. I think these are even Channel Lock brand, but something like that on Amazon should do okay. So I'm going to line it up. The goal here when you're cutting them is to get right in between your solder pads. And that way you still have room to solder on what's left. Mine was a little bit sloppy. It'll happen, but as long as you got some pad there still. If not, you're just going to have to sacrifice an LED. So, I've got that part done. The next part is just kind of figuring up your downside. So I'm going to go 2 down. And then cut a couple singles here. Just like that. So now I'm going to lay some solder on these points. And your soldering iron is another big one. If you're a weekend guy, you're just doing this for, you know, your own set of lights and you're probably never going to do it again, I get it. Use a cheap iron. If you build on a regular basis, don't be afraid to invest $100 to $150 in an iron. It can make a difference. This one here heats up really fast. I can change tips on the fly. It feels a lot better in the hand. It's not a super high-end one. I mean, they've got some that are like $500 and up, $1,000. But it's kind of like a knockoff of the JBC. I think it's JBC, whatever that brand is. But heck of a lot cheaper, and it works pretty darn good. Not going to say it works as good as the $500 ones, because I don't know, I haven't tried them. But I've been very happy with it. And as you can see, like when I hit, I'm running at 350. I'm using a broad tip so that I can transfer heat a little better to the big pads. I can change my tips on the fly. If I have a small pad or I have something else, I can do that. But it transfers the heat really fast with the big pad, so I like to use it. But you can see I'm not even on there for more than maybe 2 seconds. Sometimes I get people that will be struggling with soldering. And when they show me pictures, I can see burn marks on the strips and stuff. If you're doing that, you're touching it too much. You're on that pad too much. Maybe it's not enough heat. Some people get really scared at 350 C, but it's not the heat as much as the time. I mean, obviously you don't really want to be running like, 500 C or something, but you could go up to 4, maybe even 450 and be okay. I run 450 for wiring, and it works pretty good, mainly because wiring some of the larger, thicker stuff that I do, like 14 gauge, it does take a little bit to get that stuff to soak in, to heat up the wiring so it can soak it in. Higher heat will heat up that part faster. Lower heat will want to travel. So if you kind of think of it like that. So if you're going, 300 C, while it's trying to heat up that pad so you can get solder on it, all that heat is also transferring into the LEDs, the controller, the IC chip, the rest of the PCB, the LED itself. So it's not really ideal to have a lower heat and take longer. You want to have a higher heat and take less. But there is kind of a sweet spot, and your iron will play a role in that, as well as the solder. Solder's a big part. A lot of people go lead free. Lead free is not easy to work with. It's difficult. It can also crack, like after install, when you put it on a car, vibrations and stuff, because it's not quite as solid as leaded. So I do like leaded solder. Yeah, wash your hands. Don't go licking your solder paste. Yeah, basic stuff. Come on now. We're working with electrical, we're working with stuff like that. So, basic stuff like that, yeah. But by and large, it's safe. You can use leaded solder, you'll be fine. Alright, so back to this. So here's what we're going to do. So I got this part laid out. What I use is I have a little top of a cookie sheet here that I kept, little cookie tin, and I kept it to put all my 5mm pins. So when I do 5mm builds with 5mm LEDs, I keep the pins that I cut off, and I put them in there, especially if they're longer. If they're really short, I toss those, but keep the longer ones, and I use them for this case. And the way that I do it is I will put a pin on the side that's going to flex down. So I got that one on there. I'm going to trim it down just a hair. Actually, I'm going to rearrange that. Here's what I'm going to do, because I want to go a sharp angle on this case. So what I'm going to do is kind of put it almost below it. Just like that. If you need to, you can add a little more solder on there. Just like that. Alright, and then cut the rest of that pin off. So you can see, just like that, if it's focused, just got that connected right like that. The next step will be to connect your data. And then I will connect my 12-volt power. So there it is. I've got my power, my ground, and my data right there on the connecting with those little metal pins. And you can see I'm starting to get the shape that I want. So if I drop this in here, it lines up right where I want it. There it is. So now we're going to start finishing out the shape on the bottom. So that's a little bit more work, but I'll show you that. Now, I've seen some people use just wiring, and they'll just solder the wire and solder the wire, and you're not going to get that same rigid feel to it, for one. For two, unless you got a whole bunch, like a whole glob of wire kind of sitting there, it's kind of hard to get them close together for the pieces. So you may end up with a LED gap, whereas with this one I won't. So it's one of the benefits to using pins versus using wire. Now, as for this second part, what I'm going to do is I'm going to attach, in this case, just the ground, basically the inside pin. So attach that there, cut it down to the point where I can just add another one. Right like that. So you can see, just like that, just where it's holding on. I'm going to do another one. Just like that. So now, what I'll do is line it up. And what I'm kind of doing here is I'm just shaping it to the size that I need. So once I get it lined up to right about where it needs to be on the inside here, then I can come down here, get that out of the way, and shape the parts that I've added to be about the shape that I need it to be to kind of clear around there. So now what I'm going to do is I'm going to pull it back out, being careful not to move any of these parts that I've just bent. And then I'm going to add in the ground and the data, or the ground and the power, or well, data and power lines, to give it that extra rigidity. Alright, so I finished out the rest of this little PCB shape. Cut the rest of the strips that I needed. Use the same process throughout that. Obviously, you know, especially the first couple times you do this, you might want to double check your spacing quite a few times just to make sure that your angles and stuff are all right. So I'm going to slide that right in there. And as you can see, it fits in pretty good. So this would be a good point to test it. Make sure that everything is solid. Obvious things, you don't want your powers, grounds, and datas to be touching each other. So any of your sharp angles like up here at the top, visually inspect that, because you could fry some stuff if you don't. I'm going to grab a controller, plug it up, and see how it looks. Alright, so there we got it inside. Now I got a controller. I'm going to plug this up. And it's just sitting in there loosely, but you can see it's all shining through real well. Now another little trick when you're dealing with something like this, where you want to try to get the spacing right. I don't know if the camera's picking up on that, but you can see all the LEDs. If I push it up real close, if I space it out just a little bit, the UCS is bright enough that it will light the whole thing up. Spaced out just a little bit, so it's definitely the way that we want to try to go. A little trick that you can do is I get these coffee stirrers really cheap, like 2,000 of them for 20 bucks or something like that. I use them for mixing epoxy and stuff like that because they're really cheap. You grab a couple of them, mix them up, and they work pretty good. And they're way cheaper than the regular like tongue depressors, at least for the number that you get. And then what I'm going to do is I'm going to try to create some supports that I can put across and glue to the back of the strip, and it will kind of elevate it up from the surface. So I will create probably like 2 of them. I don't need many. And then I'm going to pull this out. So the glue I'm going to be using is a 2-part CA glue. It just works a lot faster than a lot of the other stuff out there, so it's kind of what I've stuck with. And I'm just going to apply a little bit to the back of the PCB. Stick the stick to it, spray it with the activator. Put a little bit more on the front side. And I've been using this for a while on these rigid strips, and haven't had any issues interacting or short circuiting or any of that stuff. Nothing. It seems to work really well. It cures pretty fast. I will go back over it with some like Gorilla Glue just to get it a little bit better of a kind of like a more permanent contact, but for just quick lining it up without having to hold anything, this works really well. Alright, so I got that in there like that pretty good. Like I said, I'll go back over it with some Gorilla Glue contact adhesive just to make sure that it does keep a bond. One thing with the CA, it does have the potential to break free with vibrations, like on the car. So I usually use it more like to tack weld, so I can get it into place where I need it. And then I'll go back over. So like case in point for these, the way that I secured those was a little bit of the CA glue in the middle. Once I got it where I needed it, then I hit the rest of the strip with the Gorilla Glue, because it has more flex to it. So vibrations and stuff, it can flex if it needs to, but it'll still hold. Whereas this stuff will break free with flexing, vibrations from the car, bumps, things like that. Much more of a tack weld than like a permanent bond. So keep that in mind. But hopefully that gave you guys an idea as to how I go about creating different shapes. In case anybody's wondering, the reason I didn't use the C lights on this, they're a little bit short for that top. I wanted a full length for that bar to light up. So the C lights, that is the WRX C lights that I sell, actually do fit, but I don't recommend it on the Subi speeds. I think this is a better method because you will get more density. More of the strips will be filled in, and obviously you're going to have to get these as well. We're probably going to need like 2 meters to do a set of these lights with the 8mm, so keep that in mind. I think it was around a strip for the C light, and then maybe half a strip for these. So you need about 3 strips to do these, which is 1.5 meters. I don't sell them by the half meter, so you're right at 2 meters. That extra half meter you probably gonna want just in case you need to fix anything. So definitely, if you are gonna be doing the Subi speeds, FYI, just by 2 meters. And then yeah, I did use the 8mm, like I said, because it got into here a little bit better than the 12mm would up in the corners. But you could even mix and match the 12 and the 8, and that'll work fine. Like the 12 would have worked really well in here, no problem. Maybe even up along the top right in here, but up in here, I think the 8mm works better. You could do the 12mm in here, that would work fine too. So just for this actual build, just an FYI in case you're doing that. But as far as the actual PCB shaping, that should give you an idea as to how I do it. Maybe it'll make it a little bit less intimidating. But definitely check out the site, nextlevelneo.com. We've got the UCS stuff, like I said, the 4 different rigids, including the 1 SK, the RGB UCS, and then the 2 RGBW UCSs. Definitely worth checking out. If you would like a free sample, I can send you a little section so you can check it out. Just hit me up and I can do that for you with any order that you place. So if you place an order, I can throw it in a bag or a box or whatever we ship to you, and that way you can check it out. But thanks for watching the video. Stay tuned for some future videos. Definitely still got quite a few planned out that I really want to show as I'm working through different builds. So definitely some good stuff coming. Thanks again. You guys have a great one.